In the coming days, NASA's Perseverance rover is expected to begin building the first sample depot on another world. This will mark a crucial milestone in the Mars sample return campaign, which aims to bring Mars samples to Earth for closer study. The 10 sample tubes being dropped on Mars' surface so they can be studied on Earth in the future carry an amazing diversity of red planet geology. The depot building process starts when the rover drops one of its titanium sample tubes carrying a chalk-sized core of rock from its belly 2.9 feet onto the ground at an area within Jezero Crater nicknamed Three Forks. Over the course of 30 or so days, Perseverance will deposit a total of 10 tubes that carry samples representing the diversity of the rock record in Jezero Crater. The rover has been taking a pair of samples from each of its rock targets. Half of every pair will be deposited at Three Forks as a backup set, and the other half will remain inside Perseverance, which will be the primary means to convey the collected samples to the Mars launch vehicle as part of the campaign. The samples for this depot, and the duplicates held aboard Perseverance, are an incredible set representative of the area explored during the Prime mission, said Meenakshi Wadhwa, the Mars Sample Return Program principal scientist from Arizona State University. We not only have igneous and sedimentary rocks that record at least 2 and possibly 4 or even more distinct styles of aqueous alteration, but also regolith, atmosphere, and a witness tube. How to build a depot. One of the first requirements to build a sample depot on Mars is to find a level, rock-free stretch of terrain in Jezero Crater where there's room for each tube to be deposited. Up to now, Mars missions require just one good landing zone. We need 11, said Richard Cook, Mars Sample Return Program Manager at NASA's Jet Propulsion Laboratory in Southern California. The first one is for the sample retrieval lander, but then we need 10 more in the vicinity for our sample recovery helicopters to perform takeoffs and landings, and driving too. After settling on a suitable site, the campaign's next task was to figure out exactly where and how to deploy the tubes within that location. You can't simply drop them in a big pile because the recovery helicopters are designed to interact with only one tube at a time, said Cook. The helicopters are intended to serve as a backup, just like the depot. To ensure a helicopter could retrieve samples without disturbing the rest of the depot or encountering any obstructions from the occasional rock or ripple, each tube drop location will have an area of operation at least 18 feet in diameter. To that end, the tubes will be deposited on the surface in an intricate zigzag pattern, with each sample 16 to 49 feet apart from one another. The depot's success will depend on accurate placement of the tubes, a process that will take over a month. Before and after Perseverance drops each tube, mission controllers will review a multitude of images from the rover. This assessment will also give the Mars sample return team the precise data necessary to locate the tubes in the event of the samples becoming covered by dust or sand before they are collected.